Hey, welcome back to Well, That's Interesting, the Tell Me Why People Want to Go to Space Again edition. Today is episode 241. Let's talk about these two planets disintegrating before our eyes and this zombie star moving through the galaxy at 110,000 miles per hour. My friends, if you're a long-time listener of the show, then you know the more we peer into our universe, both near and far, the things we see, the things we learn, the discoveries that rewrite what we thought we knew, all of it leaves us feeling not only in awe, but kind of just standing there with our hands on our hips, thinking, Jesus, that's the most violent thing I've ever heard. Guess I'm just going to have to go back to my day now. And this is thanks to the overachieving James Webb Telescope. Yes, week after week, we find ourselves attempting to comprehend distances, numbers, and timelines that, let's face it, are hard to wrap one's head around. Despite that, I love this shit. Space is wild, and today, I've got two stories that are prime examples. In the first half of the show, for the first time, astronomers have directly observed two worlds beyond our solar system getting railed by their sun. And what I mean by that is due to their position of being oh so horrifically close to it, the planets are burning away. I'm talking about temperatures so hot, they don't melt rock, they vaporize it. Yeah, we're vaporizing rock today, and that's just the start. We will meet these two unfortunate exoplanets, and we will learn why they're so unfortunate. We will meet the two different teams who found each one. We will look at the effects of each planet's destruction, and how astronomers are turning these lemons of death into glasses of fresh hell lemonade that they are cheering over. For real, they are super stoked about this discovery. As Nick Tissay, a graduate student in the Penn State Department of Astronomy and Astrophysics who led the study we're about to crack into, said in a statement to AAS.org, quote, "These planets are literally spilling their guts into space for us. We finally have the means to study their composition and see what planets orbiting other stars are really made of." End quote. Delightful. Then after the break, we're moving on from one star to another, but don't worry, it's just as dangerous. My friends, I'll just say it. Astronomers have discovered a magnetar speeding through our galaxy at more than 110,000 miles per hour, and after tracing its path backwards in time, we can't say for sure how it formed because we can't see the supernova or the process by which these things are created. And I can see your face from here. The expression says something like, whoa, 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 what do you mean by a magnetar? What the fuck is that? If they form from a supernova, does that mean they're stars? But whatever it is, it sounds like it's moving fast, even for space. Now, if you were thinking that, great questions. First, hell yes, 110,000 miles per hour is fast. For context, though, it's not as fast as our sun orbiting the center of the Milky Way. Our girl is hauling ass and bringing with it the planets, asteroids, comets, and other objects in our solar system at an average velocity of 450,000 miles per hour. So, this magnetar is moving. But of course, space is terrifying and there are things moving faster, like us, right the fuck now. Anyway, back to magnetars. Yes, these were once regular stars, and we will get into how they transform from a regular star into a celestial body so extreme they become the second densest known object in the universe behind black holes. Or rather, we will get into how we think they transform, and we will get into why this new one is oh so different and thus making us reconsider their birthing process. In the meantime, hi, I'm Jill Chacha, and if this is your first time listening, welcome to the flock, my newly hatched business goose. To begin, I'm going to ask you to lie the fuck down, to close your eyes, breathe in, and as you exhale, I want you to think about the size of our universe. If you're having difficulty, good. You should. It is really unfathomable. The approximate size of the observable universe is 93 billion light years in diameter. And by the time we finish this half of the show, it'll probably be larger than that because it's still expanding. And as for what's beyond, what we can see and measure, who the fuck knows? So let's just say it's 93 billion light years to infinity. Now, if you've ever had difficulty trying to locate house keys in your home, then you can imagine how challenging it could be to find an exoplanet in an area this size and in constant motion. As the name suggests, an exoplanet is a planet that orbits a star outside our solar system, so if you want to find one, your best bet is to first find a star. Luckily, there's no shortage of those, so for the sake of fucking time, we mortal humans use technology to stare at thousands of stars for every second of every day for weeks, months, and even years. The goal is to detect tiny periodic dips of light, called transits, due to a possible planet passing in front of an observed star while in a possible orbit. And once again, for the sake of time, we mortal humans use technology to do the clickety-clack calculations to determine if a scant dip in light was detected, and if that dip reoccurs in a predictable, repeated amount of time. My friends, with what telescopes and computing power we have at our disposal, as of April 27th, 2025, when I wrote these notes, there have been 5,885 confirmed exoplanets, and of these thousands, 4 of them are currently experiencing a hell so extreme, they're going to disappear from existence. Their suns are dismantling them. We're going to meet 2 of these 4 today. And thanks to their very public and messy sacrifice, we will soon know more about what lurks within exoplanets than the core of our own Earth. Let's get into it. Join me, will you, in what feels like a totally other world itself, 2015. You, me, and dozens of other equally adorable NASA nerds are poring over data coming in from the Kepler Space Telescope, a revolutionary device launched in 2009 whose purpose was to find these needles, these exoplanets, within the horrifying expanse of the haystack we live in, and to determine how common Earth-like planets are in the Milky Way, if any. Now, I use the word revolutionary to describe Kepler, and honestly, I meant every letter. Of the nearly 6,000 known exoplanets, this beast found over 2,600. To do so, it first had to locate stars, and every so often Kepler would make this completely new discovery of one. Enter K2-22. If you drop whatever bullshit you're holding right now and pick up your phone to head on over to the old social medias, on today's post, you're going to see a screenshot of K2-22 as provided by NASA's website, Eye on Exoplanets, which by the time you're hearing this, I hope is still live. Who knows? Anyway, this screenshot still exists. And as you can see, K2-22 is profoundly different from our sun. It's a red dwarf, meaning it's smaller, cooler, and, well, redder than our own. These are actually the most common type of star in the Milky Way. Due to their slow rate of hydrogen fusion, they have incredibly long lifespans, potentially lasting trillions of years. Now, when I say cooler, though, cooler than our sun, don't let that fool you. K2-22 is still a star, pumping out light, heat, and radiation. You don't want to get too close. And K2-22b is a prime example of that. This star and exoplanet system is a mere 800 light years away from Earth, so they're practically in our living room. The proximity of the duo, along with the new astonishing abilities of the James Webb Telescope, has revealed one destiny we could have had in the roulette wheel of fate. My friends, we won the cosmic lottery. And here's what I mean. Thanks to Nick Tissay, a PhD student at Penn State and lead author of the research we're breaking down right now, and Dr. Jason Wright, a professor of astronomy and astrophysics, and their team over at Penn. They had the honor of wielding James Webb and peeping into the lives of thousands of stars around us. K2-22 was one of them. And wouldn't you know it, turns out she has a close companion. Like, too close. According to the team's press briefing back in January, those dips in light we talked about earlier, those transits, on occasion they can occur every several weeks or months, once every time the planet orbits its star. But rarely Oh, so rarely, astronomers run into planets orbiting their stars every few hours because they are within an extreme proximity. And even though this is a shitty club, it is exclusive, and thus must have a name. These belong to the ultra-short period planets, or USPs for short. Our newest member, K2-22b, is so damn close to its star, its orbit, or rather its entire year, is merely 9 hours long. And the repercussions of this are a nightmare. Its surface reaches temperatures of more than 3,320 degrees Fahrenheit, and if that sounds hot to you, it is. For context, aluminum melts at around 1,200 degrees Fahrenheit. The human body is cremated around 1,800 degrees Fahrenheit. Copper melts at just under 2,000 degrees, and steel has a melting point that typically ranges from 2,500 to 2,800 degrees Fahrenheit. So steel would not stand a chance here. And neither would solid rock. It would vaporize. So with this, I would like to admit that I fibbed a little. Yep. You know how I mentioned one of the ways exoplanets are found by blocking light? Well, in this particular case, it wasn't K2-22b itself that got Nick and the gang's attention. It was its tail. Yeah, 22b has a tail of sorts. For you see, whatever organic material this planet is made of, and put a pin in that, by the way, it's not going to survive that kind of a temperature. It'll burn off, easily. And although it's 1.4 times the size of Jupiter, due to the distance, or lack thereof, from its star, 22b is still too small to hold on to that loose material gravitationally. Trillions upon trillions of particles are being pulled away from this stripped planet. And as it proceeds with its nauseatingly speedy orbit, a tail, like that of a comet, forms behind it. And it was this tail that blocked out a whopping 1% of K2-22. It was its scattered and plentiful remains that caught the team's attention, and they were fucking thrilled with this crime scene. As to why, Jason explained in the press release, quote, "It's a remarkable and fortuitous opportunity to understand the terrestrial planet's interiors. When nature gives you a gift like that, you have to take it." End quote. Yeah. The team reached deep into their being and found their inner Mariska Hargitay to create an exceptionally special unit. For the first time, a team of astronomers would be able to directly analyze the inner material of an exoplanet thanks to exceptional violence. And they did so, ingeniously. Back in April of 2024, they decided to use James Webb's sensitive mid-infrared spectrometer. Now, if you're a longtime listener of the show, then a spectrometer might sound familiar. Back in April of this year, during episode 231, let's talk about this curious case of cannibalism from 18,000 years ago and how Earth's mini-moon mystery was solved. It's more moon. One of the many devices busted out to solve that mystery was a spectrometer. To rule out the mini-moon being an asteroid, a spectrometer was used to dissect the light the object was reflecting, because asteroids, especially those from the main belt between Mars and Jupiter, are made of certain materials, and those materials reflect light in a very particular way. The light coming off this mini-moon didn't fit that spectrum. In this mystery, today, the team could analyze the light reflecting off the dust particles in the tail and compare it to reflections of materials we know of. So, after many a particle was reviewed and many a calculation was clickety-clacked, what did the Law & Order USP's Special Victim Unit find? Can I get a dun-dun? Sorry. Yes, thank you in the back. Something they totally did not expect. The dust doesn't seem to be iron, which is what scientists were expecting if 22b was a bare core, like the very center of a planet, with no mantle or crust surrounding it. Quote, "There is still meat left on the bones, so to speak," Nick said in proper New York City detective manner during that January statement to the press. Well, Nick really got into character there, but what he meant to say was that 22b may have originally formed farther from its star and migrated inward. So the crime scene is still unfolding. It's as though we walked in on it just moments after it started. Now, if that's a bit shocking to you, just wait, it gets better. As reported by Lisa Grossman of ScienceNews.org, the researchers first checked to see if the dust grains were magnesium oxide and silicon monoxide, which were expected under the crust, in the mantle of the planets, ones like Earth. But those minerals didn't fit the data. Instead, the dust looks most like nitric oxide and carbon dioxide from vaporized ice. Quote, "If that's true, what we're looking at is a snowball disintegrating. That's hard to explain for a planet so close to its star. It's just so weird and unexpected," end quote, Nick said to Science News in an interview. So, what might be happening here is an icy planet being lured in, possibly by gravitational forces of a hot body, and now it's being ripped apart. We've all been there. In the meantime, Nick and the USP's Special Victim Unit, they're hungry for more. They've requested additional time with the James Webb Telescope to perform new tests and gather more data, so this is still a developing story. And as we wait for answers, I'm happy to say something else terrible is happening as we speak, and it can keep us occupied. Join me, will you, with lead author Mark Hahn, a postdoctoral researcher at MIT, and his colleagues who have been having the goddamn time of their lives operating the Transiting Exoplanet Survey Satellite, or TESS for short. As the name suggests, TESS is designed to discover thousands of exoplanets, particularly those in orbit around the brightest dwarf stars in the sky, and so far she's bagged 620. But there's still over 7,500 under investigation. Damn, Tess. Now, one of those 600 plus happens to be another rare planet undergoing a disembowelment. And it just so happens to be the closest evaporating exoplanet to Earth discovered so far. My friends, if K222b was in our living room at 800 light years away, what's called BD 054868AB is sitting on the couch with us at a scant 140 light years away. And to be honest, what we're going to see so up close and personal is going to make what we just heard look like a minor disagreement. Mark and the MIT gang discovered BD, and is a planet who orbits its star every 30.5 hours at a distance of just 4% the distance between Mercury and the Sun. This means it's only about 2 million miles away from its star. And if that sounds awful, it really is. Temperatures again just start at 3,000 degrees Fahrenheit. And as such, BD sports not one, but two massive tails. A leading tail of larger sand-sized particles and a trailing tail with smaller soot-sized grains. Together, the tails span a whopping 5.6 million miles and occupy roughly half the planet's orbit. There's a graphic of this over at today's post if you'd like to take a look, but if you're too busy falling apart yourself, just imagine a star with a ring around it, like Saturn. Now that sounds quite a lot of material being lost. It totally is. This one is losing the equivalent of Mount Everest every single orbit. But don't worry, it gets worse. Unlike K222b, we are watching the very end of a violent fate. Losing that much material every 30 hours adds up to the loss of 10 Earths every billion years. And little BD is now only the size of the moon. So, within 1 to 2 million years, there'll be no trace of it left. Like I said, we humans, we won the cosmic lottery. Earth, motherfucking Earth, is damn special. After the break, it's a good thing we're not near anything like this either. We need to talk about magnetars and the discovery of a new one that suggests these things can form in multiple ways. Stars are getting more freaky. Next. Stay tuned.
Ryan Reynolds here from Mint Mobile. With the price of just about everything going up, we thought we'd bring our prices down. So to help us, we brought in a reverse auctioneer, which is apparently a thing.
Mint Mobile Unlimited Premium Wireless. How to get 30, 30, bit to get 30, bit to get 20, 20, 20, bit to get 20, 20, bit to get 15, 15, 15, 15, just $15 a month? Sold!
Give it a try at mintmobile.com/switch.
Upfront payment of $45 for 3-month plan, equivalent to $15 per month required. New customer offer for first 3 months only. Speed slow after 35 gigabytes if network's busy. Taxes and fees extra. See mintmobile.com.
My cat Freddie loves to be brushed and cuddled. But stirring up his cat allergens meant sneezing and itchy eyes. Then I found Purina One Live Clear. It's cat food that reduced the major allergen and my suffering in as little as 21 days. Now, we feel closer than ever. If you have issues with cat allergens, you really need to try Purina One Live Clear.
Try new Purina One Live Clear today. Purina One, a difference from day one.
And we're back. We are so back. And my friends, I have great news. Not only can stars destroy the objects around them, they can also destroy themselves. Stars, like our gorgeous sun, primarily use hydrogen to create nuclear fusion, specifically hydrogen protons that fuse to form helium. This process, known as the proton-proton chain, releases immense energy as light and heat. And stars, the mass of our sun, run out of hydrogen after 6 billion years or so, upon which they begin fusing that helium, causing the core to shrink and heat up, while the outer layers, they expand and they cool, making the sun appear red. This expansion is so dramatic it makes Saturn eating his sun look totally normal, as our motherly sun will engulf Mercury and Venus. And as for us, well, don't worry, it'll be worse. Quote, "We do not currently have consensus whether Earth could avoid being engulfed by the red giant sun in 6 billion years. In any case, planet Earth will only be habitable for around another billion years, at which point the Earth's oceans will be vaporized by the runaway greenhouse effect, long before the risk of being swallowed by the red giant." End quote, said Dr. Qiming Zhang from the University of California, San Diego, in a statement to berkeley.edu. So, that's that for us. However, with this ending, something does come anew. After what's called the red giant phase, the sun will shed its outer layers with an explosion. And this forms a planetary nebula, a sexy expanding cloud of gas and dust and elements that will eventually condense to help form other objects, like new fucking stars, and thus entire solar systems. Fun fact, nearly all the gold on Earth can be traced to its formation in stars, and its delivery was through furious events like these explosions and supernova and neutron stars colliding. Put a pin in those last two, though. They'll show up again. So that's an incredible fun fact that always blows my mind. But anyway, back to our sun and stars like it, which after that shedding leave behind a core. It will be incredibly dense and hot, though relatively small, about the size of Earth. We call these white dwarf stars. And that's it. Now, if you're a longtime listener of this show, then you know there are big mamas out there. There are stars that are way, way more massive than our sun. And when these run out of fuel, well, a beautiful hell breaks loose. After fusing heavier and heavier elements, the star's core collapses under gravity, triggering a shock wave that travels outward. The shock wave heats up and compresses the outer layers of the star, causing that to explode at incredibly high speeds, aka a supernova. What remains can be one of two things: a good old-fashioned hole, meaning a black hole, or a neutron star. And it's equally as insane. A neutron star is basically a core, only a few miles across, but my God, it contains 10 to 25 or even more solar masses, meaning, for example, 25 suns are stuffed into a space only 10 to maybe 20 miles in diameter. As a visual, the island of Manhattan is 14 miles long. So how the fuck do you compress all of that mass into such a tiny area? Well, everyone, please imagine an atom. Thank Thank you. At the center, there is the nucleus with its protons and neutrons, and swinging around them are electrons, and everyone's happy and has elbow room. Looks great. Now, it just so happens this imaginary atom here is in a star that's about to pop off and become a neutron star. My friends, the core's collapse is so intense, the extreme pressure causes the electrons and the protons to combine, and this forms additional neutrons. And that space that was between them, that's gone. It's removed. According to the wiki, surpassed only by black holes, neutron stars are the second smallest and densest known class of stellar objects. A fucking teaspoon of a neutron star would weigh 4 billion tons on Earth, so please, don't take any. And guess what? There's 3 varieties of neutron stars. That's right, there's 3, each fucking crazier than the last. If you head on over to the socials and swipe through today's post, I've got a handy-dandy graphic from NASA about our kooky collection. But the one we're going to cover today is all the way to the left, a magnetar. Now, these are neutron stars that have the added perk of being even more magnetic than me. I'm kidding, but for real. According to science.nasa.gov, quote, a magnetar has a magnetic field about 1 trillion times more powerful than Earth's magnetosphere. If a magnetar flew by Earth at half the moon's distance, its intense field would wipe out every credit card on Earth. If a human got within 600 miles, the magnetar would become a proverbial death ray, ripping apart every atom inside the body. End quote. Jesus. Thank you, NASA. That's great to hear. It's so magnetic, it can pull apart your body on an atomic level. You're probably wondering why the hell it's like this, and to be honest, we're still trying to figure that out. There are only 30 known magnetars in the Milky Way, so the sample size is small. And it doesn't help when one of them is so weird, it brings up more questions than answers. Join me, will you? In 2008, when researchers using NASA's Swift Observatory detected brief, intense flashes of gamma rays 15,000 light years away, and coming from what would become a new discovery, a magnetar that they dubbed SGR 05014516. Additional fun fact and quick quirk about magnetars, on occasion, they have little outbursts. And what I mean by that is that they throw out high-energy radiation and gamma rays into the universe. You know, gamma rays. Devastating electromagnetic radiation arising from the radioactive decay of atomic nuclei, which is a fancy way of saying, depending on the strength of that outburst, these rays can do anything from deplete the ozone layer to potentially wipe out all life on a planet. Anyway, let's ignore that and focus on what else the team saw at the time. 0501 was located close to a supernova remnant called HB9. It was so goddamn close, according to science.nasa.org, the separation between the magnetar and the center of the supernova was just 80 arc minutes, or slightly wider than your pinky finger when viewed at the end of your outstretched arm. All signs were pointing to this new magnetar having been born the usual way, a supernova. And the case was closed, and everyone moved on. Well, not everyone. Turns out, space nerds always be nerdin'. And I'm talking about the wonderful nerds Joe Lyman of the University of Warwick, Andrew Levan, an astronomer at Radboud University in the Netherlands, and their NASA colleagues who wanted to reopen this case. And this time, they opted to use Hubble's upgrades rather than rely on ground telescopes, like what was used back in 2008. With it, they were able to peer back in time just a smidge to spot the magnetar's faint infrared glow and track it with more accuracy back in 2010, 2012, and 2020. So, with their clickety-clack calculations, what did they find? Drumroll, please. Thank you again in the back. This thing is speeding alone through the galaxy at 110,000 miles per hour, which is faster than originally thought. With this new information, the team was able to trace the magnetar's trajectory thousands of years into the past, and they showed that there were no other supernova remnants with which it could have been associated. So long story short, 0501 was not born from a supernova. So where did it come from? One more time, drumroll please. We're not sure. Nope, not a clue. But researchers do have a theory, and it's called accretion-induced collapse. Now, on one hand, that sounds relatable, and on the other, a little bit confusing, so I looked it up. Remember white dwarfs? Like what our sun will become? Well, on occasion, these stars have a neighbor. Another star close enough where the white dwarf pulls in and siphons gas from that neighbor. This very unneighborly theft essentially causes the white dwarf to grow and become too massive to support itself, leading to an explosion, and thus, maybe, create a magnetar. 0501 could also be the result of two neutron stars colliding and merging, but that's not as scandalous. Either way, this roaming oddball has no proven supernovas are not always the case when it comes to creating. Nature finds a way. And thank you for listening, rating, subscribing, telling your friends about how planets they could just burn away. They could just burn away. And then, continue eating your salad or whatever that you're having while you're hanging out with your friends. Tell them about this zombie star. We don't know where it came from. And an explosive thanks to the folks over at Airwave Media, the podcast network to which WTI belongs. If you love this show, and you do, you love the other podcasts in this family, and please, stay interesting.